In this video, we will look at how to select and stake a point using Leica Captivate field software. Staking a point should be, and is, a relatively straightforward process involving just 3 simple steps. First, selecting the data to stake out, then following on-screen navigation, and finally, storing the result. This video has been created using a total station as our sensor. However, it could just as easily have been made with a GNSS receiver. Therefore, what we cover in the video applies whether we are working with a TS, an MS, or a GS. So let us now have a look at that in full speed. We choose our job, we choose our app, we then select the point we want to stake, we follow our on-screen navigation with numerical values telling us how far we need to go, and the screen or arrow showing us the direction. Then, when we are happy with our results, we simply press store to log the point and have Leica Captivate mark that location with a peg. That was at full speed. This time, let's slow it down. We begin by selecting our job and point. First, we must select the working job. This is where any results and data that we record during staking will be stored. Also, if we do not select a specific design data job, then this working job will also be the source of our design data. More information about working jobs and design data can be found in separate videos. Here, we are happy to use one job for everything, so we have that in the center of our job carousel, and then we just have to select the Stake Points app from the app carousel. Inside the app, we can see how the screen is split between information on the left and graphics and navigation on the right, plus a central button that would make the right-hand side fill the entire screen. Next, we select which point we want to stake, simply by tapping on it in the 3D viewer, or by using the point ID prompt in the information area, which takes us to a list of all the points in our job. We can then scroll through this, select our desired point, and have that set as a point to stake. Another option is to select the point from elsewhere in the software and jump into the stake app, and this is exactly what we will do now. With the same job active, we go into the 3D viewer and take a look at our data. Once we have found the point that we would like to stake, we simply select it and then press and hold to bring up a context-specific menu, from which we select Stake Point to be taken directly into the Stake Points app with the correct point automatically selected. The Stake app has numerous views available for use. The first one we will look at is the system-wide 3D free view. This is the same 3D viewer that we are able to see throughout Leica Captivate. We're able to zoom, pan, and rotate the view freely. Using this view when we are staking also gives us information about how far we are from the target in plan position, our current height, our height difference, and also we're able to see our current position linked to the target with a solid black line, indicating the direction in which we need to travel. Whilst this view is fantastic for the freedom it gives us in allowing us to fine-tune our view and understand where we are in relation to the entire job, there are other views which often we'll find even easier. Luckily, switching between the views is simple. We tap the I button on the right-hand toolbar, then we can select between a 2D free view, this 3D free view, a navigation view, or a traditional stake arrows view. So let us now have a look at each of these in turn, starting with the 2D free view. This is similar to the view that we just looked at, in that we can zoom and pan around freely, and we navigate by having our current position and target linked in the viewer, and output information at the bottom of the screen guiding us to our target. As with the 3D free view, this gives us a nice overview, but for the highest efficiency, it is typically better to use a true stake view, such as the Navi or navigation view. This is a 3D view optimized for the task of staking. We get an arrow on the screen telling us the direction to go in and a number telling us how far to go. Now, as we begin to move around, not only do these two update, so does the direction of our view in the main screen. It is as if the camera is following us as we walk around. As we skip ahead and get close to our target, we see that not only does the viewing direction change, so does the viewing angle, as it transitions from being behind the pole to above our target point, making it easier to fine-tune our position and complete the task of staking. The final view to look at is also specific to staking and is a traditional stake arrows view. As with the Navi view, because this is a stake-specific view, it is incredibly efficient. Here we can clearly see not only if we have to go forwards, backwards, left or right, but also by how much. In this example, those directions are from behind the instrument, but that can be changed as we will shortly see. But first, let's see what happens when we get close to our target. Here, the view switches to a bullseye view. This helps greatly when fine-tuning our position close to the target. To get the most from this view, we are actually able to configure how the navigation arrows and distances are computed. To see this, let's first make the graphics full screen and then start making some changes. First, we can enter into the settings for our Stake app and configure our graphical navigation. In the Graphics tab, we have a Navigate Arrow Types option, where we can switch our arrow style from in, out, left, right to direction and distance. Let's quickly see what the direction and distance option looks like. As we can see, it's clear we have to turn clockwise and move away from the total station. However, let us go back into settings, leave the option as in, out, left, right, and change what we are using to help us navigate. Currently, it is from behind instrument, but we can change that to any one of a number of options. Here, we will use facing point and then choose a point, using OK to confirm and return to the stake screen. Now we can see we need to orientate ourselves based on that specific point. If we know where that point is and want to use it as a reference behind us so we're getting directions away from the point, we can simply press Flip View from the second level of function keys to switch our directions to being based on us facing away from the point. This functionality adds to the power of Leica Captivate in allowing us to see our directions in the way we want and need them. We switch to Facing Point as our Help Me Navigate option, but there are other choices we can pick from, like from behind the instrument, facing the instrument, the sun, north, the last measured point, or a selected point, using a defined baseline, or following an arrow. The first 7 options are similar to what we have already seen, but with different objects used to help us. But the following arrow method is quite different, so we will take a look at that now. The arrow in this view actually works the same way as the Navi view does. As we walk around, the arrow is constantly updated to point us in the direction we need to go. So to use it best, we just walk forwards and then follow the arrow. As we saw when we were in the settings screen, there are also other options we can configure. So that is exactly what we will now look at. As before, we'll enter into the settings screen, but this time we will look at all of the page tabs, starting with General. The first option here is to automatically select the next closest point. This allows Leica Captivate to select the most efficient next point to stake. Then we have the ability to show the information from a user-defined page on the left-hand side of the stake screen. If we activate this, we can then pick which page to display. And the last option is where we can configure how our stake result will be stored, here with a prefix before the design point ID. That is everything from the General page tab, so let's now move to the Graphics page tab, where we have already seen the top few settings in action, so we can skip to Beep Faster when getting close to the point. This functionality acts just like parking sensors on a car, where the frequency of the beeps tell us when we are getting close to our target. We can actually configure the beeping by defining which distance type to use. Here we will use horizontal distance, and also we can set how far away we want the beeping to start. The next page tab is Quality Control, where we have the ability to make sure that Leica Captivate does quality control checks for us. When staking a point, these checks are split between a 2D distance check and also a cut fill height check. We're able to configure the limits of these checks, knowing that any data outside of these limits will be flagged and brought to our attention. Next, we have the Heights page tab, where we can unlock the ability to edit the design height of the point we are staking, and where we can apply an offset to the height of all the points we stake. Then we have a TS-specific page tab, containing some options only available when working with a TS or MS instrument. First, there is a Do Not Change Stakeout Values Between Distance Measurements, which is very useful for when we want to note down some of the stake information, but we are locked to a prism that might be moving. Then, there's the option to have the instrument automatically turn to aim at the location of the next point to be staked. Then, the option for Leica Captivate to tell us how far away the next point to be staked is from our previous point or from our instrument. And finally, we have the option to make sure that all measurements are done in 2 faces. The last page tab is then Report Sheet. This is where we're able to automatically create a report sheet as we work. However, we will leave this turned off. Now it is time to have a look at all of the settings we configured live in action. Firstly, we can see that we now have 2 pages in our information area, including our user-defined survey display mask as well as our normal stake information. Now as we get closer to the point, in fact within 2.5 meters, we can start to hear the beeping. This beeping increases in frequency as we get closer and closer to our point, and then when we get within half a meter, our view switches to the bullseye and the beeping continues to increase in frequency. This continues until we reach our quality control limit. We then hear a bing and the beeping stops. Once we are happy, we can store that measurement. However, because we configured a 2D beep, but we set quality control for all 3 dimensions, we have actually tried to store a point that exceeds our quality control in height. Leica Captivate automatically flags that up for us, allowing us to decide if we will store it or not. Here, we will store it anyway and will return to the stake screen, where Leica Captivate has already selected the next closest point for us, maximising our efficiency. With that done, we can now bring this video to a close.